Hello everyone, my name is Siddhant Kannan, USN 1VE22CS 151, and today I will be discussing Introduction to ANOVA, which comes under the subject Mathematics of Computer Science. Here are some of the contents that will be covered: definition of ANOVA, types of ANOVA, why do an ANOVA and not multiple t-tests, why ANOVA instead of multiple t-tests, ANOVA assumptions, and ANOVA examples. Analysis of variance. Here is the basic definition of ANOVA. Analysis of variance, also known as ANOVA, is a statistical test for detecting differences in group means when there is one parametric dependable variable and one or more independent variables. Here's a little bit extra about ANOVA. Many studies involve comparisons between more than two groups of subjects. If the outcome is numerical, ANOVA can be used to compare the means between groups. ANOVA is an abbreviation for the full name of the method analysis of variance, which has been invented by R. A. Fisher in the 1920s. Why do an ANOVA? When there are three or more means being compared, statistical significance can be ascertained by conducting one statistical test, ANOVA, or by repeated t-tests. Here are a few types of ANOVA: one-way ANOVA and two-way ANOVA. A one-way ANOVA has just one independent variable. For example, difference in IQ can be assessed by country, and country can have 2, 20, or more different categories to compare. A two-way ANOVA. A two-way ANOVA, are also called factorial ANOVA, refers to an ANOVA using two independent variables. Expanding the example above, a two-way ANOVA can examine differences in IQ scores, the dependent variable, by country, independent variable 1, and gender, independent variable 2. How do types of ANOVA differ? So, a one-way ANOVA has only one independent variable and only one p-value is obtained, whereas a two-way ANOVA has two independent variables, three different p-values which are obtained, and the outcome is of a factorial design. Why ANOVA instead of multiple t-tests? If you are comparing means between more than two groups, why not just do several two sample t tests to compare the mean from one group with the mean from each of the other groups? Before ANOVA, this was the only option available to compare means between more than two groups. The problem with the multiple t-test approach is that as the number of groups increases, the number of two sample t-tests also increases. As the number of tests increases, the probability of making a type 1 error also increases. ANOVA F statistic. If variability between groups is large relative to the variability within groups, the F statistic will be large. If variability between groups is similar or smaller than variability within groups, the F statistic will be small. If the F statistic is large enough, the null hypothesis that all means are equal is then rejected. Here are a few ANOVA assumptions. The observations are from a random sample and they are independent from each other. The observations are normally distributed within each group. The variances are approximately equal between groups. It is not required to have equal sample sizes in all groups. Thank you for watching. We have now come to the end of this video. Please like, comment, and subscribe, and I will see you in the next video.